Hi everyone. In this problem, we have to merge k sorted list. We are given an array of k linked list. Each linked list is sorted in ascending order. Merge all the linked list into one sorted linked list and return it. So this problem might look very complicated, but in actually right, even though it's a hard problem, but I would say it's a medium to difficult problem. It's not that difficult, right? So one thing to understand right out here. Let's say we have this linked list, right? And it's an array of linked list. Okay, so 1 4 5, then 1 3 4, then 2 and 6. Our question is, right, let's say, do I know how can I merge to linked list? How to merge to linked list? The answer is, if it's yes, right, I can create a function, let's say def, and I can say merge, and here I can pass L1 linked list 1 and L2, and I can say if L1 and L2, if both of them are existing, then I'm going to compare it. So if L1 dot val less than L2 dot val, in that case I can say, and also I always keep on forgetting that we also have to create a dummy linked list. So I can say dummy equal to linked list, and I can say cur equal to dummy. And now if I can say cur dot next equal to L1 and L1 equal to L1 dot next, because let us take this one, right? I'm going to compare, or let's say take this one, right? I'm comparing 1 3 4, 1 3 4, 2 and 6. Initially, right, both of my pointers are at here. I'm going to compare which is the smaller one. So this is the smaller one, so I'm going to say increment the pointer to here, and in my new list, right, add this one, else cur dot next equal to L2 and L2 equal to L2 dot next. And now once we have added this, so I have to increment the dummy pointer also, right, to add the next value. So I can say cur equal to cur dot next. That is the idea. Now I have added 3. So out of 3 and 2, which is the bigger one? Which 3 is the bigger one, right? So we are going to add 2 and increment this pointer. So out of 3 and 6, which is bigger one? The bigger one is 6. So we are going to increment the pointer, and we are going to add 3 out here. So out of 4 and 6, it is going to be 4. And now all the values are exhausted, right? So L1 would be empty now, or L1 would be null. In that case, right, this loop, or it's not if, it would be while. So if while loop would exist, and then I am going to say, right, cur dot next equal to L1 if L1 or L2. That basically means, right, whichever list is not empty, so add all the remaining. In case, right, it's 6 and 9, something like that. So I'm going to say add 6 and 9 all at once, and I can then say return dummy dot next. So we are able to understand, right, how we are going to merge to list. Now the question is, right, how can we create so many linked list and merge it. So here, right, I can say I can create a function def split, and I can pass in L and R. So I can say if L equal to R, then I can say return, and also here would be one value would be list, and so it is going to contain the array of list. So lists of L. So that is the idea. Now we are also going to create a mid value. So mid equal to L plus R double divided by 2, and here I can say left array equal to, and here I'm going to keep on calling the function split, and here it's going to have lists L and mid, and right array is going to contain, which is going to recursively keep on calling this split until we got individual element, and here it will be let's mid plus 1 and R, and here I can say return, and this is going to call this merge left array and right array. I know it's kind of bonkers, right? We have added this, and if I look into the time complexity, right, now to understand the time complexity, right, so to merge two list, it is going to contain sorry, big O of n, and to call the recursive call, it is going to be log k. So the overall time complexity would be in log k. So that would be the answer. If not, so in case, right, it's an empty, then I can say return none, else I can call return, and I can call the self dot merge divide function, and here I can pass in let's 0 length of let's and -1, and here I can create the function merge divide, and here I will have let's also left of the for the left half and right. Now I can say if left equal to right, this would be my base condition. So let's of L, else I can say I can call the mid to get the middle value, so left plus R double divided by 2, and it would be left merged with self dot merge divide, and here I can call let's left and right, and I can call right merge with self and merge divide with let's left and right. Okay, one mistake I made, right, because it would be dividing it up, right, it would be mid, and here it would be med plus 1. So that's a small tweak that you have to make, and I can again from here, right, I can call the return merge function. So I told you, right, you have to merge two sorted linked lists. So I can call the, and it will be self dot merge because they're calling class function, and here I'm going to pass in left merge and right merge. Let me create the function merge, and here I can say L1 and L2 for two linked list. Let me create a dummy, so it would be list node, and here I can also create one more function which is cur equal to dummy dot next. Now I can say while L1 and L2, I can say if L1 dot val less than L2 dot val, I can say cur dot next equal to L1 and L1 equal to L1 dot next. Similarly, I can say else cur dot next equal to L2 and L2 equal to L2 dot next. Once that is done, I can call cur equal to cur dot next, and at last I can say cur dot next equal to L1 if L1 exists, else it would be L2, and I can say return dummy dot next. And here, right, if you look into the problem, right, so we are basically first, right, we have a array of linked list. So you are splitting the linked list and keep on splitting it until we get one individual component. Once we get that individual component, let's say one single linked list, we kind of merge them. So we call this merge function, and with that merge function, once those merge is called and we merged it, we get one linked list. So after that, we'll keep on dividing and merging to get the result. So that's the idea. So here, right, we are using the principles of divide and conquer. Let me say, it says it calls, yeah, I made a one mistake. It would be, means I want to send the values not in this way, but yeah, let me run it back again. Yeah, I forgot to add self out here, which is a common mistake. Self, and here also I need to pass in self. Yeah, here I'm calling left. It should be, let me say it as left and right only, then left and right, left and right. Let me run it back. One more area, left and right. Let me run back. I hope it works. How many areas I have to change? Left. I'm making some mistake out here. Okay. Very. It will be dummy, right? Not dummy dot next. See, in this small thing I'm making so many mistakes. Just be careful, and in case, right, if error comes, you can always run and get the result. Let me submit the code. As you could see, the code got submitted successfully and it is beating 64.32% submission, which is pretty efficient. That's all for this video. See you in the next one.